Hi guys, I'm Argur Rahman. Uh, I'm a master student in Cardiff Metropolitan University in data science. So, uh, this is my final assessment for CMP 7005, and this is the famous dataset for air quality in China between 2013 to February 2017. So, there is five tasks I need to do. The first one, um, so for Python language, I need to import some libraries, and this is the uh, essential library for running my program in Python. So there was another task to connecting my Google Colab to GitHub, so I can make the app from directly GitHub to uh, Streamlit Cloud. So there is the my GitHub email, username, and the repo token, everything, and I connect to GitHub, and from here, start task one. Task one, basically, I need to read uh, data handling. So how I handle the data, uh, this is the main part for data handling. It's the task one. So to handle data, first I read the data, and I combine the data, because there are total data sets set in my final assessment. So there is the uh, row and column. Task 2 is fundamental data understanding. Say, I want to see now my data column and row. There are total 18 column and 4 lakh to 20,768 rows exist there. So now I find two missing data in my data set. So there is a code for finding missing data in data set. Missing heat map, and so now my task is data pre-processing. So this is the part where I mm, work with data. See, every data have some problem or null value or something like that, and unwanted row column. So there is the first I try to find missing value per station. There is the full statistics missing value in for per station. Now, see, there is too much data. So that's why this is a small quantity. If I compare with my full data set, there are more than 4 lakh data is exist there. So this is 600, 900. It even it less than 1%, so I can drop this data. So I dropping all the missing values. So now my heat map is too much good. See, there is no missing data, and now I combine the um, whole air quality data set. So now I want to some visualization. Say, find I try to find escalator board temperature temperature versus pressure. So see, this is the escalator pod. and then I try to find some histogram and box plot. So there is the histogram and the box plot, and now I want to find for every column like NO2, CO, uh, O3, temperature, pressure, and rain something for every column. Now I want to show some bar chart. It's also look good for visualize. So now I want to tell. I want to see how correlated column to depend it with other. So I want to try find correlation matrix of numerical feature. See, this is the correlation matrix of numerical feature. So there are some also pair plot. The pair, pair, so it's only depend for numerical values. Say some now the statistics part of my dataset. The main thing of my dataset is uh, whole data. So I want to plot some continuous uh, uh, time continuous time graph, like there will be some and I can compare with them each other, like my parameter will be month, and the independent variable will be P25, NO2, SO2, CO3. So this is the uh, numerical value, and this is the chart mean level by month station. So this is for the 2.5, NO2, SO2, CO2, mean O3. See, there is a setback for my visualization is the for box plot. I don't print any figure or something like that, because it will be too much. It take too much process time and visualization, so I can't re-upload in my GitHub. That's why I just didn't pin the box plot there. And see some visualization subplot for day. uh, First I show month, then day, and this is the day station. So this is the hour station. See, this is hour station, and this is the and for tax 3 I build a model. So basically, when I saw I handling data, I preprocess the data and show some visualization. But main part is to build a model, because the model, uh, I need to see my mean square, uh, see my mini square, root mean square, mean absolute error, and r squared. So say uh, first I need to divide it data into two part. One is testing, one another is training. So test, I taking 30% data for testing and 70% data for training. So I tried different proportion, like 20% or 80%, 20% and 80%, or 25% or 70%. It depends on uh, me, or see, there is a build of a model by KNN regression. So I built KNN regression to build my model, and I use pipeline also, preprocessed column transfer. and this is the my training result. My training result is not good. I tried, but see, there is a I need to do more work there. Say whatever mini square error is low, that means your model is too too good. As much as it depend on vice versa. Like if the mini square is decreasing, your model will be more good. So the root mean square, mean absolute error, and R squared, and I saw the actual and predicted values. Actual and predicted values. See, the actual value is this, and the red line is my predicted values, and the residual power. And say this is for task 4. This is my application development. So when I click on this, it will take my application, stimulate application. So I made a simple app because this is my first time I working on app, and so I didn't cut make like other do. So I just make a basic app. See the introduction. It is a multi-page app. So their introduction I can write whatever I want, like the air quality, the air quality, everything, something like that related with that. And so this is the data overview. See, this is the data overview. Okay, this is the basic statistics. This is the visualization. So my visualization is that much good, but it's okay. First time I'll try better, and next time. See, uh, this is the box plot of my uh, Python program. Uh, Interactive box plot of PM2 by hour in station, and this is loading. So for uh, every uh, pollutant have one box plot. Like see, this is for a city, this is for hour, and something like that. So I want to train now. I want to show you the train model of I make. It's running. It takes some time. So and see, my model is not that good. I should uh, if you want to work on this project, you can try another like random tree, and the random tree forest also good. Vector regression also good, and many other regression you can use. So So this is my app train model. uh, See, there is too much the mean square error, too much for root mean square and mean absolute error, and r square. So it should be low to make a better impact. And mm, and this is the final tracks version control. So see, our one of the main target also was that we need to make a repository in GitHub and upload the all dataset there and work from GitHub, so mem can see when we did change, when we work, what we change, when we change, what. So everything is there. See, you can see there is many commit history. So something when I change something, I upload it in GitHub, that this is my and you need to change the commit history. So this is the GitHub repository commit history.